This video is about microphones. So a microphone is a transducer that converts the variations in air pressure or sound to variations in electrical voltage or analog signal. The signal is called analog signal because the electrical voltage is a direct analog to the air pressure. As the pressure in the air goes up and down to make the sound waves, when that gets converted to electrical energy or analog signal, the electrical charge goes up and down to match the air pressure. It's an analog. So microphone's a transducer. The most common type of microphone is a moving coil microphone, or maybe I should say the simplest to understand. But all of them work on similar principles. So a moving coil, the capsule of a moving coil microphone has a diaphragm, a coil, and a magnet. So the diaphragm is a thin piece of material, sometimes paper, sometimes other synthetic things, that is so thin and light that as the sound waves hit it, it moves. And it moves analogously to the sound wave. So the coil is then attached to the diaphragm, and the coil sits within the field of a magnet. So when the diaphragm moves, it moves the coil within the magnetic field, and that creates electrical current that goes positive and negative based on how the thing moves, which again is analogous to the sound wave. Now, it's never exactly what the sound wave is, right? Like microphones vary in some ways and color the sound in some ways, but that's the basic premise of how it works. Now, there are some different types of microphones. The one that I just described to you is called a moving coil microphone. That's a type of dynamic microphone. There's another type of dynamic microphone called a ribbon microphone that works on a slightly different principle. Instead of a coil in a magnetic field, it's actually a little metal ribbon, and they're sensitive in some different ways. And on another video, we'll have some examples of that. And then there's a whole other class of microphones called condenser microphones, which we'll get to in a minute. So here are a couple examples of some moving coil microphones. The one on the left is a Sennheiser 441. For a person with my job, I'm bad at microphone numbers. There's a 441 and a 421. That's a 441. I hate it when I space that. I'm pretty sure it's a 441. This is going to be on YouTube, so this will be embarrassing. Anyway, that's a Sennheiser. It's a moving coil microphone. The one on the right is a Shure SM57. You've probably seen lots of both of these. They're both pretty popular microphones. The SM57 might be the most popular microphone in the world, along with its sibling, the SM58. Those, like the SM57, I bought my first SM57 probably 30 years ago, and it cost about $100, and you can buy one today for about $100. And they're great. You can mic loud stuff with them. Pretty much anything. You can stir your cocktail with it. It might still work. Use it to defend yourself. It's a pretty tough microphone. So these are moving coil microphones. The other type of dynamic microphone are called ribbon microphones. These you definitely do not want to use to defend yourself or stir your drink. Ribbon microphones are much more sensitive. They have a very smooth, warm sound usually that people tend to like, but they can be much more fragile. So the one on the left is a Coles. The one in the middle is an old RCA microphone that is probably worth $10,000 now if it's in great shape. The one on the right's an AEA R84. We have both the Coles and the AEA in the studio here at school. And I'll have some other videos that will give you some sense of what they sound like. But those are ribbon microphones. And then condenser microphones are designed a little bit differently. The capsule's made up of a diaphragm and a backplate that you apply to a charge to it. So you have to send power to a condenser microphone. And when that charge is applied, it forms a capacitor. So again, when the diaphragm moves in relationship to the back plate, it generates a voltage. Condenser mics require phantom power, so if you see a button that says plus 48 volts, that's what that means. And they tend to be much more sensitive because there's this applied power to them. They can really react to sound quickly and pick up very subtle aspects of the sound. So here are some examples of some condenser microphones. On the left is an AKG C414. I think that one's an XL2. There are a number of versions with different endings. You see on the front that it's got a switchable pattern, and we'll talk about the patterns in a second. The one all the way on the right is a similar microphone made by Shure. And then in the middle, the two in the middle are small diaphragm condenser microphones. You'll see a number of them that look like this. These particular ones are Samson CO2s, but lots of companies make small diaphragm condenser mics that look like that. So those would be things that you might see on, drum overheads or things like that. And we'll have another video where you'll get to hear each of the different types of the microphones, and we'll do some of that live in the class portion too, for those of you who are in person. Now, every microphone has a polar pattern or a pickup pattern. This is the way the microphone reacts to sound. So if you look in the bottom left, you see the one called cardioid. It's called cardioid because the shape is sort of shaped like a heart. So you see the little blue thing. So if the sound were coming from the right to the left at the 0 marker, a cardioid pattern microphone picks up sound really well in front of it and a little to the side, and it rejects the sound pretty well behind it. So if you look in the bottom right corner, a hypercardioid microphone pattern picks up well in front of it and a little bit behind it, and actually has some better rejection of sound to the sides. If you go to the top right, the one that's called dipole in this diagram, but most often it's called figure 8. So that microphone picks up well to the front and the back and rejects sound pretty well to the sides. And then an omnidirectional microphone picks up sound all around. And we'll do a little demonstration later to let you see how those things work. So there's your basic microphone facts.